Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, a history of science in 100 experiments. Hôm nay chúng ta sẽ đọc truyện số 49, The Monk and the Peas. Sometimes the significance of experiments is not widely appreciated at first, either because they received little publicity or because they do not fit into the framework of current thinking, or both, as in the case of Gregor Mendel's investigation of inheritance in peas. Mendel was a monk based at a monastery in Brno, then part of the Austro-Hungarian Empire, but now in the Czech Republic. He was also a trained scientist who had studied at the University of Vienna. This was not an unusual combination in those days. The same monastery also had a botanist and an astronomer among its rank, and it was an intellectual as well as religious center. Mendel's main role in the community was as a teacher at a local school, but from 1856 onward, he also had time to carry out a series of experiments on the way in which heredity works in pea plants. He chose peas because he knew that they had distinctive characteristics that bred true and which could be analyzed statistically. The characteristics he studied included whether the seeds were rough or smooth, whether they were yellow or green, and so on. What made this work special for the time was that he approached the study of biology like a physicist, carrying out repeatable experiments, keeping detailed records, and applying proper statistical tests to analyze what he saw. He started out with some 28,000 plants and chose 12,835 for detailed investigation. Each plant was identified as an individual, and records of its descendants were kept like a family tree. He had to know the parents, grandparents, and so on of each plant in succeeding generations, so he had to fertilize every flower of thousands of plants by hand, dusting the pollen from a specific single plant onto the flowers of another specific single plant. Then he had to analyze the nature of the resulting seeds, plant them, tend the next generation of plants as they grew, and repeat the whole process. It took him 7 years to determine the way the characteristics he was studying were passed on from one generation to another. Mendel studied 7 characteristics in all, but we can understand what he found using the rough, smooth example already mentioned. He discovered that there is something in a plant that is passed from one generation to the next and determines the nature of the offspring. That something we now know is a package of genes, and we shall use the term to describe what Mendel found. Even though he did not use it himself, he referred to hereditary elements. Mendel's statistics showed that the properties he studied related to pairs of genes. There is a gene for roughness, R, and a gene for smoothness, S. A single plant must inherit one possibility from each parent. So it may contain any of the possible combination of RS, or SS, right? It passes one of these on to the next generation. An RR, or rough, or SS, smooth plant has no choice but to pass on R or S respectively. But an RS plant will pass on R to half of its offspring and S to the other half. RR plants always give rough seeds. Well, R is rough. SS plants always have smooth seeds. S is smooth. But what happens in RS plants? The statistics show that in this case, the R is ignored and the P's are all smooth. The evidence came from crossing plants that always produce rough seeds, RR, with plants that always produce smooth seeds, SS. Only 25% of the offspring had rough seeds, while 75% had smooth seeds. This is because 25% of the offspring are RR, 25% are SS, and the rest adding up to 50% either RS or SR, both of which give smooth seeds. Mendel's results were published in 1866, but their significance was not appreciated. It was only at the end of the 19th century when other researchers independently discovered the same laws of inheritance that his papers were rediscovered and he was given the credit he deserves. The laws of inheritance that Mendel discovered are of key importance in understanding the theory of evolution by natural selection. First, they explain why offspring do not have properties that are a blend of the characteristics of their parents. Offspring of a cross between R and S plants always come out either rough or smooth, not some slightly wrinkled middle compromise. This had been a key puzzle since the publication of Darwin's Origin in 1859, because such blending would remove or at least reduce the variability of which natural selection operates. Secondly, Mendel showed that each characteristic is inherited independently. Whether or not the pea is green or yellow, for example, does not affect whether it is rough or smooth. The next step toward an understanding of the mechanism of evolution would be taken by Thomas Hunt Morgan early in the 20th century. For the vocabulary section, let's practice inheritance. Inherit is a verb, inheritance is a noun. Monk, and a monk lives in a monastery. Intellectual, intellectual. Religious, religion, religious. Heredity, Analyzed statistically, not tickly. Analyzed statistically. Repeatable experiments. Descendants, offspring. Package of genes. Hereditary elements. Hereditary element. Elements. Laws of inheritance. Laws of inheritance. Laws of inheritance. Theory of evolution by natural selection. Theory of evolution by natural selection. Theory of evolution by natural selection. Practice makes perfect, right? Well, thank you for your time. I appreciate it. And as usual, I will see you in the next story. Bye for now.